Alright, hello, welcome to the topic 11A review. This is covering topics 11.1 and 11.4 for the upcoming test. Let's get started. Looking at number 1, it wants us to graph y equals 1 over x plus 3. It wants us to give the domain and range as well as the asymptotes. So first, I notice that I have a plus 3 right there. That means my graph is going to shift up 3 units. So instead of my instead of my horizontal asymptote being at y equals 0, we're going to be at y equals 3 because it always equals my k value. I do not have a shift left or right, so that means my vertical asymptote is still going to be at x equals 0 because it hasn't moved. So I'm going to go ahead and draw those asymptotes first. So x equals 0 is right here along the y-axis. And then y equals 3 is 1, 2, 3. It's going to be right here. Okay? And then I do not have a stretch or compression, so let's start about right there and draw like so. Again, we don't expect perfection on these graphs, but just kind of get the general idea. So that's my graph. Now looking at domain and range. Remember, domain and range, they cannot be equal to our asymptotes. So for my domain, x can be all real numbers except for 0. It cannot equal 0 because that's where my asymptote is. And then for range, same idea. Y can be all real numbers except it cannot equal 3. So looking at number 2 is the same idea. We have y equals 1 over x minus 2. And again, it wants the domain and range and asymptote. So on this one, this minus 2 means I'm going to move to the right 2 units. So my vertical asymptote is also going to move right 2 units, and it's going to become x equals 2. We do not have a shift up or down, so my horizontal asymptote is going to stay at y equals 0. So I'm going to go ahead, y equals 0 is my x-axis. And then x equals 2 is right here. Do not have a stretch or compression or a reflection, so go ahead and just draw like so. And draw like so. Now for domain and range, my domain, remember, it cannot be equal to my vertical asymptote, so that means x can be all real numbers except for 2. Can't equal 2. Range, it can't equal that vertical asymptote, so that means y can't equal 0. Okay, so again, domain and range, it can be all real numbers except wherever your asymptotes are located. Looking at 3 and 4, 3 says what value of y is not included in the range for y equals 1 over x minus 5 and y. So to know what's not included, we need to know where our horizontal asymptote is. That minus 5 tells me the horizontal asymptote is y equals negative 5. So that means for my range, y cannot equal negative 5 because we cannot equal our horizontal asymptote. So y cannot equal your horizontal asymptote. Number 4 is asking the same idea, except it's asking for the x value not included in the domain. And the function on this one is y equals 1 over x plus 12. So again, I know vertical asymptote is going to be x equals negative 12 because you have to flip the sign. And so that means my domain is going to be x cannot equal negative 12 because x can't equal my vertical asymptote. Again, your asymptote is a barrier that your graph cannot cross or touch. Looking at number 5, it's wanting us to write the domain and range of the translation f of x equals 1 over x graph below. So this is some transformation. We don't exactly know. It doesn't give us the equation right off the bat, but I do see the asymptotes. And I can see this horizontal asymptote is at 0, -1, -2. So this is y equals -2. And then looking at my vertical asymptote, this is -1, -2, -3. X equals -3. And so because that is where my asymptotes are, those values cannot be included in my domain and range. So for this, my domain is going to be x cannot equal -3, because again, -3 is where that asymptote is located. For range, same idea. It's going to be y cannot equal -2, because again, -2 is where that asymptote is located. Number 6 is asking us to write an equation. All right, it's asking us to write an equation for the translation of y equals 4 over x that has an asymptote at x equals 7 and y equals 6. So because your asymptotes cannot tell you your a value, I told you, all right, it tells us that the a value is 4. So we know it's going to be y equals 4 over something, and then we may have a k value. X equals 7, remember the vertical asymptote, that is related to your h. Remember, since h is backwards, you have to flip the sign. So if this is a positive 7, we're going to write it as x minus 7 in my equation. The y equals 6, that is my horizontal asymptote, and that is related to k. Since k is straightforward, we don't need to switch signs or anything, so this is a positive 6. We're going to say plus 6 for my equation. Now these next three are just simply asking us to simplify these rational expressions and state restrictions. We cannot forget restrictions. First thing I got to do is I've got to factor everything. So I'm going to factor number 7. So this is going to become t minus 8 on the bottom can't be factored, so he's going to stay t minus 8. On top, looking at factors of -32, looking for a sum of -4, I am going to choose -8 and +4, because that multiplies to be -32 and that adds to be -4. So we're going to get t minus 8 and t plus 4. Now looking at my denominator, again, it's my factors in the denominator that determine my restrictions. So if I set t minus 8 equal to 0, I would get a t value of 8. So we're going to say that t cannot equal 8 because we don't want this denominator equaling 0. I'm going to go ahead and cancel out stuff. So I'm going to cancel out those t minus 8s, and we're going to be left with t plus 4 as my answer, with a restriction that t cannot equal positive 8. Looking at number 8, switch colors here, I'm going to have to factor both the numerator and the denominator. So looking at the numerator, we have k squared minus k. Remember, that is a 1k minus 2. So if I factor -2, looking for a sum of -1, that's going to be -2 and +1. So we're going to get k minus 2 and k plus 1. Same thing for my denominator, factoring -5 to get a sum of -4. That would be -5 and +1. So we're going to get k minus 5 and k plus 1. Go ahead and list my restrictions. I'm going to say k cannot equal, it can't equal +5 from here, because solve this one for k, we get +5. And then k plus 1, set it equal to 0, we're going to get a -1. So k cannot equal +5 or -1. And now to cancel stuff out, those k plus 1s cancel, and I am left with k minus 2 over k minus 5 as my answer, with restrictions of k cannot equal +5 or -1. Switching colors one last time to do number 9. Again, I'm going to have to factor both my numerator and my denominator. So I'm going to factor a 24, looking for a sum of -10. That means both of my factors have to be negative. So that means -1 and -24, for example. It's not the pair I want. I want a -4 and a -6, because those add to be -10. So we're going to get n minus 4 and n minus 6 on my numerator. Denominator is going to be 18. Factoring 18, looking for a sum of negative 9. So same thing, I'm going to end up with two negative factors. So for example, negative 1 and negative 18. But the pair that we want for this is going to be negative 6 and negative 3. So we're going to say n minus 6 and n minus 3. Looking at my restrictions, we're going to say n cannot equal positive 6 and positive 3 because you set both of these equal to 0 and solve. My n minus 6's cancel, and I am left with n minus 4 over n minus 3. Looking at the next three, we are asking to find the product this time and still state our restrictions. Looking at number 10, I don't really have anything to factor here. I can just go ahead and make this one giant fraction. And I can go ahead and multiply these two together. 10 times 10 would be 100. 3 over 100 will not simplify, so that is going to go ahead and stay with a 3 on top, 100 on bottom. Looking at my g's, I have a g to the 5th on top, a g squared on bottom. I'm going to subtract those. 5 minus 2 is 3, so I'm going to end up with a g cubed on top. Same with my h's, h to the 5th, h squared, 5 minus 2 is 3, so I'm going to have an h cubed. On this one, refer to your topic 9-1 notes if you're a little confused on 10. 9-1 notes, please. Looking at 11, I'm going to have to do some factoring first, so I'm going to go ahead and factor this stuff out. Y squared, nothing we need to do there, so we're going to go ahead and keep him. Y squared minus y minus 6, that's factoring a negative 6 to get a sum of negative 1. That would be a negative 3 and a positive 2, so we're going to say y minus 3 and y plus 2. Looking on the bottom, y squared plus 1y, we're just going to factor out a y from that. So we're going to say y, and then what's left inside is y plus 1. And the y minus 3, we'll just move him on over. Looking at restrictions, y cannot equal 0 because just setting y equal to 0 is y equals 0. Y plus 1, set it equal to 0, you can't get negative 1. And then y minus 3, set it equal to 0, you get a positive 3. So these are my restrictions. Go ahead and cancel out these y minus 3's. Right here, I have a y squared on top, y on bottom, 2 minus this is an exponent of 1. I'm going to end up with, I'm going to end up with a y and y plus 2 on top. And then on bottom, this guy goes away. We're ending up with just y plus 1 on bottom. Looking at 12, 12 is similar. So when I rewrite him, it's one big fraction, that b squared on top is going to stay. B squared plus 5b minus 6. So we're factoring a negative 6, but this time for a sum of positive 5. So that would be a positive 6 and a negative 1. So we're going to get b plus 6 and b minus 1. Looking at my denominator, b squared minus 4b, take out a GCF of b and left with b minus 4. And then b minus 1 just gets to be brought on down. All right, simplifying this out, looking at b minus 1, those are going to cancel. And then b squared and b to the first. This one's going to go out, and I'm going to be left with a 1b on top because 2 minus 1 is 1. We're going to get b times b plus 6, and then b minus 4 on bottom. Almost forgot my restrictions. Go ahead. We're going to say b cannot equal 0 from setting the b equal to 0. Setting b minus 4 equal to 0, it cannot equal 4. Setting b minus 1 equal to 0, it cannot equal 1. All right, the next three, the final three, we're going to be dividing. So these are going to take a little bit more work, but we will make it through. So again, it's asking us for the quotient in simplest form, and we need to state our restrictions just like we have been. Just remember, on division problems, your quotient comes from both denominators and then the numerator of the second of the second fraction, only because we have to flip that fraction. So I'm going to start by rewriting this. I'm going to say a plus 2 over a minus 5 times, and then I'm going to flip the fraction. I'm going to say a squared minus 8a plus 15 over a plus 1. Now I'm going to go ahead and factor it. We'll write it as one gigantic fraction this time. We're going to say a plus 2 on top because that one's fine. If you're factoring 15, looking for a sum of negative 8, you are going to get negative 5 and negative 3 because they both need to be negative to get a positive product but a negative sum. So we're going to say a minus 5 and a minus 3. And then we're just going to bring these two guys over. There's nothing to do with them. A minus 5 and a plus 1. So looking here, the only thing that cancels is a minus 5. So we're going to end up with a larger answer here. We're going to end up with a plus 2. Oop, got a little messed up there. And then a minus 3 on top. And we're going to end up with a plus 1 on bottom. Now, going back real quick for my restrictions. Again, restrictions we're going to get from here, here, and here. So just to bring that on over, that's the a minus 5, the a plus 1, this trinomial here. In factor form, that's both of these on bottom, and then that's these two on top. So I need to set all of these equal to 0. And so for that, we get restrictions of, starting with the a minus 5, a cannot equal 5. A plus 1, that gets us a negative 1. A minus 3, that gets us positive 3. And then a minus 5 is repeated again, so I don't need to write that one twice. So this is your answer. You got more restrictions than usual because it's division, and then this is your answer. For the sake of space, I'm going to go ahead and erase. So if you need to copy this down, please pause the video. And I will do this for 14 and 15 as well. So, looking at 14, again, I need to go ahead and flip this fraction. Do the keep change flip. So we're going to do b plus 6 over b plus 5 times b squared plus 8b plus 15 over b plus 4. Gonna go ahead, again, this is factoring 15, but we want a sum of positive 8, so we can leave this as a positive 3 and a positive 5 this time. So to write it as one gigantic fraction, we're gonna get b plus 6, b plus 3, and b plus 5 on top. On bottom, I can just simply write both of these because they don't need to be factored. So we're going to get b plus 5 and b plus 4. The b plus 5s cancel. So my answer, my quotient is going to be b plus 6 and b plus 3 over b plus 4. Now, looking back at my restrictions, and I know I'm doing these backwards by doing the restrictions last. This is how I find it easier. If you want to do the restrictions before you cancel stuff out, please feel free to do so. So my restrictions come from this b plus 5, this denominator here, this trinomial, and then the b plus 4. So looking over here, b plus 5, b plus 4, this. Translating it down here, it's these two and these two. So that means my restrictions, b cannot equal, starting with b plus 5, it cannot equal negative 5. B plus 4, that is going to be negative 4. B plus 5 is repeated, don't need to write him twice. B plus 3, that is going to be negative 3. So these are my restrictions for this quotient. And again, pause the video if you need to write this down, because I'm going to erase to leave room for 15. All right, looking at 15, this one's a little more complicated, but same idea. We're going to start by doing keep, change, flip. So going to keep the x squared minus 16 over x squared plus 5x plus 6. Now multiplied by x squared minus 2x minus 8 over x squared plus 5x plus 4. So now I'm going to factor all of the things. We're going to write one gigantic fraction here. X squared minus 16 is a difference of two squares. The square root of 16 is 4. So this is going to become x plus 4 and x minus 4. My other numerator here, x squared minus 2x minus 8. If I factor negative 8, looking for a sum of negative 2, we're going to choose negative 4 and positive 2. So we're going to have x minus 4 and x plus 2. Excuse me. Looking at my first denominator, we're going to factor 6, looking for a sum of 5. So again, factoring 6 for a sum of positive 5. It's going to be 2 and 3. So we're going to have x plus 2 and x plus 3. My second denominator, we're looking for a product of 4 that gets us a sum of 5. So that's 1 and 4, because 1 plus 4 is 5. So we're going to get x plus 1 and x plus 4. This one's got a lot going on, but we can still cancel out plenty of stuff. X plus 2 cancels. The x plus 4s cancel. Unfortunately, nothing else does, so we're going to end up with a larger answer here. We have 2x minus 4s. So an easy shorthand way to write this is x minus 4 squared, because squaring something means multiplying it by itself. And then on bottom, those are not the same, so we'll have to write out x plus 3 and x plus 1. And again, restrictions. That's going to be from both of my denominators, my second numerator. So over here, both denominators, second numerator. X squared plus 5x plus 6 became the x plus 2 and x plus 3. X squared plus 5x plus 4 became x plus 1 and x plus 4. X squared minus 2x minus 8 became x minus 4 and x plus 2. So we got a lot of things going on here, but some of these do repeat, so it'll make it a little easier. But we're going to say x cannot equal, starting on the bottom. Setting x plus 2 equal to 0, we get negative 2. Setting x plus 3 equal to 0, we get negative 3. Setting x plus 1 equal to 0, we get negative 1. X plus 4 gets you negative 4. X plus 2, already wrote that one, don't need to repeat. X minus 4, you get positive 4. So again, this one has a lot of restrictions, but that is normal because this is a division problem. So that is going to wrap up our 11A review. If you have any questions whatsoever, go back and look at your notes, go back and watch the note videos, or ask your teacher. Study hard, do well on your test, and have a great day.